Let's consider how to find the sum of two sines or two cosines using complex numbers. It is given that V1 is 6 sine of 80 plus 30 degrees. In general, it may be in radians, it doesn't matter. And V2 is 6 sine of 80 plus 90 degrees. And when it find V1 plus V2, it means the sum of two sines. How to do that? First of all, how to represent the sine as a complex number. If we consider such a complex number, 6 cosine of the same argument 80 plus 30 degrees plus I sine of 80 plus 30 degrees. It's we can see that it's a complex number of a form, it's modulus argument form, r cosine theta. It's another theta, not this theta. It's in general we use theta. Plus I sine theta. And we can see that our sine is the imaginary part of such a complex number. So we can say that our sine of 80 plus 30 and multiplied by 6 is the imaginary part of such complex number. If it would be cosine, it will be the real part. And we know that this form also can be rewritten as r e to the power of I theta. It's called the Euler's form or the exponential form. So it becomes the imaginary part of 6e to the power of I and this argument 80 plus 30. And absolutely similarly, so let's rewrite. So V1 is the imaginary part of 6e to the power of I 80 plus 30. And V2 is also the imaginary part of 6e to the power of I 80 plus 90 degrees. And hence V1 plus V2 becomes the imaginary part of the sum 6e to the power of I 80 plus 30 degrees plus 6e to the power of I 80 plus 90 degrees. And we can use a calculator to add complex numbers, but the problem is A. We cannot add two complex numbers if a letter, some parameter is present. So an idea is the next. We need to factor out this e to the power of I80. How to do that? It looks like 2 to the power of 3 plus 5, and we know that it's what? It's 2 to the power 3 multiplied by 2 to the power of 5. So let's split it. Okay, so it's imaginary 6e to the power of I80 multiplied by e to the power of I30 degrees plus 6e I80 multiplied by e to the power of I90 degrees. And now we factor out this e to the power of I80 and it becomes 6e to the power of I30 plus 6 to the power of I90 degrees. And this can be added using a calculator. Or if it contains some simple or useful angles for which exact values of sine cosine we know, we can use the formula again that it's 6 cosine. Here it's 6 cosine of 30 plus I sine of 30 degrees. But in general, we can use just a calculator. And how to do that? First of all, we should choose mode and radians or degrees. I will use radians because I don't know why, but when I choose degrees, I get an incorrect answer. And here we should choose this re to the power of I theta. And then just enter 6 multiplied by e to the power of I 90 degrees, or pi over 2 I in radians, plus 6 e to the power of I 30 degrees, or pi over 6 I in, if it's in radians, and just enter, and we get the answer. It's 10.4 to 3 significant figures e to the power of something I, and it's argument but in radians, and to convert in degrees, just multiply by 180 and divide by pi, and we can see 60.0 degrees to 3 significant figures, or since it is given to 2 significant figures, we can write just 60 degrees. So this is what 10.4 e to the power of I 60 degrees. I multiplied by 60 degrees, and also the imaginary part e to the power of I 80 and multiplied by this answer. And the next step is we need again combine these two e to get a single e. So again use, it looks like 2 to the power 3 multiplied by 2 to the power 5, and we know that it's 2 to the power 3 plus 5. So it becomes the imaginary part 10.4 to 3 significant figures e to the power of the sum, and we can factor out I, so it becomes 80 plus 60 degrees I. It doesn't matter I is here or in front. And using the formula that re to the power of I theta, it's r cosine plus I sine, rewrite again as cosine of 80 plus 60 degrees plus I sine of 80 plus 60 degrees. And now we take the imaginary part, and the imaginary part, it's this part, a complex number should be represented as something plus I something, and it's called the imaginary part. This one is the real part. If a few I values arises, for example, if it looks like this, 3 plus I divided by 5 minus 2i, you cannot say what is the real part, what is the imaginary part. You should simplify or rearrange in some way so that you get something plus something I, and only when it is written in such form you can say that it's the real part, it's the imaginary part. So the imaginary part is just 10.4 sine of 80 plus 60 degrees, and it's the required answer. And a common question is to find the maximum or minimum value of this function. We know that usual sign changes in between -1 and 1. Endpoints are included, but if it is multiplied by some value, so now sign changes in between -10.4 and 10.4, and it's called a range of this function. So maximum of this function is 10.4. So question is expressed in the form V sine at plus theta. So V is 10.4, theta is 60 degrees. If it would be cosine, it will be absolutely the same, but it should be the real. You should write real, but everything absolutely the same. Real, 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 and finally you get cosine. So cosine plus cosine, you will get finally cosine. Sine plus sine, you will get finally sine. And that's all for this question.